रिलेशन एंड फंक्शन चैप्टर के फर्स्ट पार्ट में मैंने आपको बताया था कि 90% स्टूडेंट्स को पता होता है कि रिफ्लेक्सिव रिलेशन, सिमेट्रिक रिलेशन, ट्रांजिटिव रिलेशन क्या होता है। और 90% स्टूडेंट गलत आंसर लिखते हैं कि रिफ्लेक्सिव, सिमेट्रिक और ट्रांजिटिव करेक्ट वे क्या है लिखने का, उनको पता नहीं होता। तो आज एक दो एग्जांपल्स के थ्रू हम सीखेंगे कि इन क्वेश्चंस के आंसर करेक्टली कैसे लिखने चाहिए, क्या क्या स्टेप्स हैं जो आपको लिखने चाहिए ताकि आपको उसमें फुल मार्क्स मिल सके, आप कोई भी मार्क्स इसमें लूज ना करें। एक क्वेश्चन के थ्रू हम इसको डील करते हैं। क्वेश्चन इज, set A is given to us. Set A has elements between 0 and 12, and R is a relation on set A. R is a relation on set A defined by R is equal to, अब ये रिलेशन है, it has ordered pair AB such that mod of A minus B is a multiple of 4. You have to show that it is an equivalence relation, show that it is an equivalence relation. Also find the equivalence class element 1, equivalence class of element 1. This is a rider which we generally get. So how do we write down the correct answer of this question? Let us see. First of all, we have to check the reflexivity. तो याद रखिए, इसमें मैंने पहले भी बताया था आपको एक जनरल सॉल्यूशन देना है, एक पर्टिकुलर सॉल्यूशन इसमें बिल्कुल नहीं चलेगा, क्योंकि जहां पर आपको इक्विवेलेंस रिलेशन प्रूव करना है वहां पर एक एक जनरल सॉल्यूशन से आप प्रूव करते हैं, पर्टिकुलर एग्जांपल्स लेके नहीं करते। फॉर रिफ्लेक्सिविटी आप याद रखिए जो हमने पिछले वीडियोस में आपको बताया हुआ है, वी पिक अप वन एलिमेंट फ्रॉम सेट ए, एनी रैंडम एलिमेंट, एंड वी रिप्रेजेंट दैट एलिमेंट बाय ए। सो लेट एलिमेंट ए बिलोंग्स टू सेट ए। करेक्ट। रिफ्लेक्सिविटी के लिए आपको पता है ए और बी दोनों की जगह हम ए सब्स्टिट्यूट कर लेते हैं और स्टेटमेंट की ट्रुथफुलनेस चेक करते हैं। जो रिलेशन दिया हुआ है उसकी ट्रुथफुलनेस चेक करनी है। रिलेशन है मॉड ऑफ ए माइनस बी इज ए मल्टीपल ऑफ 4, तो ए माइनस ए हो जाएगा, ये इज ए मल्टीपल ऑफ 4। आप ये स्टेटमेंट लिखिए और इसकी ट्रूथफुलनेस चेक करिए कि ये सही भी है या गलत है। एंड वी नो दैट ए माइनस ए, mod of a minus a is a multiple of 4 is a true statement, because a minus a is 0 and 0 is multiple of 4, means 0 is divisible by every number, so 0 is divisible by 4 also. So mod of a minus a is 0, that's why. Correct. And therefore a comma a, ordered pair a comma a, satisfies the relation, and it is true for all the elements which are present in set A. Therefore R is reflexive. ये बिल्कुल 100% करेक्ट वे है इस क्वेश्चन को रिफ्लेक्सिविटी लिखने का, इस क्वेश्चन में। तो आप ये स्टेप नोट कर लीजिए, ऐसे ही लिखना है आपको आंसर हमेशा। देन वी कम टू सिमेट्री। ऑल ऑफ अस नो दैट इन सिमेट्री what happens, AB belongs to R we know and BA belongs to R we prove। तो उसके लिए क्या जस्टिफिकेशन है, लेट अस सी। सिमेट्री के लिए यू आर अलाउड टू पिक अप टू एलिमेंट्स फ्रॉम सेट ए, let A and B be two elements of set A such that, आपको दो एलिमेंट इस तरह से पिक करने हैं कि उनका ऑर्डर्ड पेयर रिलेशन को सेटिस्फाई करता है। दैट इज यू आर सेइंग रिलेशन को सेटिस्फाई करता है मींस that mod of A minus B is a multiple of 4 is a true statement. This statement is true. And we know that mod of B minus A is same as mod of A minus B. मॉडुलस वैल्यूज सेम होती हैं, राइट? और जितने भी एलिमेंट्स इस सेट में प्रेजेंट हैं उन सबके लिए ट्रू होगा ये. So mod of B minus A is equal to mod of A minus B. So in the above statement, in place of A minus B, I can write down B minus A. Therefore, mod of B minus A is a multiple of 4 is also true. If this is true, it means B comma A, ordered pair B comma A belongs to R, means satisfied that relation. Therefore, R is symmetric. I hope you are getting this. Now we shall prove the transitivity of the relation. For transitivity, we can pick up 3 elements from the set. Let A, B, C belong to set A such that the 3 elements have been picked up in such a way that ordered pair AB belongs to R and ordered pair BC belongs to R, and we have to prove that ordered pair AC belongs to R. So ordered pair AB belongs to R means mod of A minus B is a multiple of 4 and mod of B minus C is a multiple of 4. BC belongs to R means mod of B minus C is a multiple of 4. Now when it says mod of A minus B is a multiple of 4, let us take mod of A minus B as 4m and mod of B minus C as 4n, where m and n are natural numbers. So mod of A minus B is 4m, so A minus B will be plus minus 4m and B minus C will be plus minus 4n. क्योंकि मॉडुलस के साथ इक्वेशंस को ऐड नहीं कर सकते, इसलिए पहले आपको मॉडुलस को रिमूव करना है. So now adding these two equations, when you add these two equations, what you get? A minus B plus B minus C is equal to plus minus 4m plus minus 4n. So B and B will get cut. We get A minus C is equal to plus minus 4 common m plus n. Now plus minus 4m plus n. Now I remove plus minus and I put modulus on the other side. So this is 4 times m plus n, which is a multiple of 4. So we conclude that mod of A minus C is a multiple of 4. Mod of A minus C is a multiple of 4. This is true. So this implies ordered pair AC belongs to R. Therefore, R is transitive. Correct? Now, since R is reflexive, symmetric, as well as transitive, therefore, R is an equivalence relation. right? Now the writer of the question was you have to find the equivalence class of element 1. So it means that if I take A as 1, what are the values of B so that mod of A minus B is a multiple of 4 is a true statement? Because the statement is mod of A minus B is a multiple of 4. Now let A is equal to 1 because you have to find the equivalence class of element 1. So we assume A is 1. Then what can be? Then B can be uh, B can be 1, B can be 5, and B can be 9 because 1 minus 1 0 is a multiple of 4, 1 minus 5 4 is a multiple of 4, 1 minus 8 1 minus 9 8 is a multiple of. So the elements in set A are from 0 to 12. So out of those elements 1, 5, 9 are the elements which can be paired with element 1. So equivalence class of element 1 is 1. This is how we write it, 159. So equivalence class of element 1 means elements which are related to 1 is the set of elements 1, 5 and 9. Now this is the best way to answer the question. I hope this is clear to all. Now we come to the next example. Next example is prove that relation R on set n cross n defined by AB is related to CD. Ordered pair AB is related to ordered pair CD, which implies and implied by that A plus D is equal to B plus C for all ordered pairs AB and CD which belong to n cross n. We have to show that it is an equivalence relation. So let us check the reflexivity first. You should understand the meaning of this, that ordered pair AB is related to ordered pair CD. This implies A plus D is equal to B plus C. What does it mean? That the first element of first ordered pair and second element of second ordered pair are added and their sum is equal to second element of first ordered pair is equal to the sum of second element of first order pair with first element of second order pair. So this is how you should understand this. So we relate the ordered pairs like that. Let us check the reflexivity. Now in reflexivity, you are allowed to pick up one element only. In this case, we shall pick up one ordered pair. Let us pick up one ordered pair AB. Let ordered pair AB belong to n cross n. Now we have to check whether ordered pair AB belongs to ordered pair AB. How it is done, that we have to see that. Now we know that A plus B is equal to B plus A. Why it is so? Because sum of natural numbers is commutative. We know this. Sum of two natural numbers is commutative. Right? Now if you are applying this result to the given relation A plus B, now in place of D we can see we have B and in place of C we have A. You compare the relation with the given relation, compare this result with this, and you will come to know that it is ordered pair AB is related to ordered pair AB, right? And it is true for all ordered pairs because sum of all natural numbers is commutative, means if we are taking two at a time for all AB belonging to n cross n. Therefore, R is a reflexive relation. You must write down the reason why it is so. So again, here also we have written the result in 4 lines. So first of all, you should pick up one element from the set. Then you should check the truthfulness. If it is true, then ordered pairs satisfy the relation, and it should satisfy for all the elements which are present in the given set. Then R is reflexive. Now we check the symmetry of this. For symmetry, you're allowed to pick up two elements. So here we shall pick up two ordered pairs. Let AB and CD belong to n cross n, and these elements, these ordered pairs have been picked up in such a way that they satisfy the relation that AB is related to CD. This implies A plus D is equal to B plus C, right? Because it is given the relation. Now, if you just go to the rough work and check what we need. In this case, we need CD is related to AB. CD is related to AB. It means in this case, you need C plus B is equal to D plus A. It is always helpful. You should always go to the rough work and see what we want and how we can get that. So we want to prove that CD is related to AB. For that, I must have C plus B is equal to D plus A, whereas I have A plus D is equal to B plus C. So from that, I can easily get C plus B is equal to D plus A. How? Let us see. This implies B plus C is equal to A plus D. I have interchanged the sides, that I can do. Now B plus C can be written as C plus B, and A plus D can be written as D plus A, because for the same reason, addition of natural numbers is commutative. If you are writing B plus C, you can write down C plus B also. If you are writing A plus D, you can write down D plus A also. So addition of natural numbers is commutative. Right? So if you look at this, because you have got this result C plus B is equal to D plus A, now you can easily say that ordered pair CD is related to ordered pair AB, therefore R is symmetric. I hope this is clear to all. Then we have to prove the transitivity of this relation. For proving the transitivity, we are allowed to pick up three elements, in this case, three ordered pairs. So let order pair AB, order pair CD, order pair EF are picked up from n cross n such that AB is related to CD and CD is related to EF. Now, in this case, we have to prove that AB is related to EF. You know that. So how we do that? Let us see. So AB is related to CD means A plus D is equal to B plus C. And here we get C plus F is equal to D plus C. Adding these two results, A plus D plus C plus F is equal to B plus C plus D plus E. Now let us see what gets cancelled. D and D will get cut. C and C will get cut. What we are left with? We are left with A plus F is equal to B plus E. This implies ordered pair AB is related to order pair EF. Therefore, R is transitive. Hence, R is an equivalence relation because it is reflexive, symmetric, as well as transitive. Hence, R is an equivalence relation. This was the simplest way of writing the answer and the correct way of writing the answer, in fact. So I hope it is clear to all. Now, after that, we shall uh, come to some important points on the basis of which some MCQs are asked. कुछ ऐसी बातें हैं जिन पे MCQs काफ़ी जिन पे बेस्ड होते हैं, तो वो कुछ फैक्ट्स हैं, वो मैं आपके साथ शेयर कर रहा हूँ. This is very important sheet of facts which I am going to share with you. It is related to relations and functions. Now suppose set A has P elements, number of elements in set A is P, number of elements in set B is Q, then number of ordered pairs in Cartesian product is equal to number of elements in Cartesian product is equal to PQ, number of relations from A to B is 2 raised power PQ, number of functions from A to B is Q raised power P. Third, number of reflexive relations, number of relations which are reflexive. I'm telling you which are reflexive. This is 2 raised power n into n minus 1 when relation is from set A to set A and n is the number of elements in set A. N is the number of elements in set A. So number of symmetric relations, two raised power n into n plus 1 by 2. This is number of symmetric relations, and there is no fixed formula for number of transitive relations. You can remember the chart which I am giving you for transitive relations. So for transitive, you can do one thing. If this is number of elements, and this is number of transitive relations. There is no fixed formula, but you have to calculate transitive relations every time you are given certain elements. So I'm sharing with you that if there is zero element, there is no element, then number of transitive relation will be 1. If there is one element, number of transitive relations will be 2. If there is 2 elements in the set, number of transitive relations will be 13. If there are 3 elements, number of transitive relations will be 171. If there are 4 elements, number of transitive relations will be 3994. So you should remember this chart for finding the number of transitive relations. And number of equivalence relations are found according to Bell formula. This is number 4. I'm sharing with you. Just wait for a minute. Number of equivalence relations is found according to Bell's formula. Bell's formula is like, if it is 1, then write down 1. It is 2, write down 1 and 2. Just add these two, whatever number you have up and down, write it in the and उसको राइट में लिख लो. ऊपर और नीचे दो नंबर्स हैं, इनको ऐड करके राइट में लिख लो. फॉर 3, 1 और 1 को ऐड करोगे क्या मिलेगा? 2. टू और वन को ऐड करोगे क्या मिलेगा? थ्री। थ्री और टू को ऐड करोगे क्या मिलेगा? फाइव। इफ देयर आर फोर एलिमेंट्स, देन टू और थ्री को ऐड करके यू विल स्टार्ट विद फाइव। सो फाइव एंड टू को ऐड करके क्या मिलेगा? सेवन। सेवन एंड थ्री को ऐड करके क्या मिलेगा? टेन। टेन एंड फाइव को ऐड करके क्या मिलेगा? 15. तो number of equivalence relations will be 2 if there are two elements. Number of equivalence relation will be 5 if there are three elements. Number of equivalence relation will be 15 if there are four elements. You can keep this result in mind. You should remember this result. So this is number of elements and number of equivalence relations. Number of equivalence relations. For two elements, we have two equivalence relations. For three elements, we have five equivalence relations. For four elements, we have 15 equivalence relations. You can continue like that, right? Then we come to number of injective functions, number of one-one functions. वो कैसे find करते हैं? So this is another important thing. So again, we come back to this. Number of elements in set A is P. Number of elements in set B is Q. And F is a function from A to B. Then number of injective functions. Injective means one-one functions. This is equal to, how do we find out? See, number of injective functions. If P is greater than Q, then number of injective function is 0. You cannot find. Number of one-one functions is 0. If P is less than equal to Q, then number of one-one functions is equal to Q factorial divided by Q minus P factorial. Sixth formula, number of surjective functions. Surjective means 1, 2. So if P is less than Q, number of surjective functions will be 0. And if P is greater than equal to Q, then number of surjective functions are given according to this formula. Summation R from 0 to Q minus 1 to the power R, and this is QCR and Q minus R raised for P. This formula is little longer formula, and even you can find the number of onto functions by using this formula also. Total number of functions, which is Q raised power P minus number of functions which are not onto. This is another way to find out number of surjective functions. Q raised power P minus number of functions which are not onto. For example, if there are set A has m elements and set B has 2 elements, number of elements in set B is 2, suppose, right? So total number of functions is 2 raised power m minus there are two possibilities for the function which can be not onto, and that is 2, right? So this is number of onto functions. That is another way to find out. But in this case, you should be very careful to find the number of functions which are not onto, right? And the last is number of bijective functions. Number of bijective functions. F is a function from set A to set A. Then number of bijections will be n factorial. Where n is the number of elements present in set A, right? So these are few important points on the basis of which certain MCQs are asked. So functions जो पार्ट है इस चैप्टर का वो हम फोर्थ एंड फिफ्थ वीडियो में कवर करेंगे। तो फर्स्ट थ्री वीडियोस में मैंने आपको रिलेशन बहुत डिटेल में बता दिया, उसके आंसर्स कैसे लिखने हैं, कौन कौन से इंपॉर्टेंट पॉइंट्स हैं, मैंने काफ़ी आपको उसमें डिटेल में समझा दिया है। सो फोर्थ एंड फिफ्थ पार्ट में हम फंक्शन कवर करेंगे। थैंक यू।